Also, before you guys leave today, you're going to do a little quiz. Most people are getting hundreds on it. If you pay attention, you're going to do really well on it. Okay? Ask questions if something you don't understand when we first get into it. At the bottom of this paragraph, it talks about a particular type of bonding. What bonding is it talking about at the bottom of that last paragraph? I think it's right, like the last sentence too, Melissa?
Chemical?
Yeah, chemical bonding, but a particular type of chemical bonding.
Ionic.
Ionic bonding. Okay? So I want to get real specific. Chemical bonding is more of a general theme. Chemical bonding is how atoms are held together to form different types of compounds. Okay? We want to get specific. So we're going to talk about ionic bonding. And this is review. Okay? So what we're going to do is talk about this thing called ionic bonding. And again, you don't have to write this down here. Let's talk about some things involved with ionic bonding. Can you guys come up with some terms, kind of brainstorm some terms related to ionic bonding?
Ion.
Yep. Now there's two types of ions. Thank you for saying that, Austin. But there's two types of ions. So we've got ions, and they are what? Charged atoms, right? You guys agree with that? They're either negative or positively charged. So let's get more specific. What kind of ions are we talking about?
Negative and positive.
Right, but there's an actual name for that, so that when we say it, we know. What's that?
Anions.
Cations.
Yeah, we got cations, and then we have anions, or anions. Cations and anions. I don't know. I've never called it that way. I've always said cations and anions. Okay? I don't know what you say, well, you're a chemistry teacher, you should know. It's been a long time. Anion, they call them, or cation, but cations and anions, what's I call them. So what's the difference? What do we know about a cation?
Positive.
It's positive, right? How do you know it's positive?
I just remember cat.
You just remember cat. Any other way to remember that, Adam?
There's the T.
Yeah, the T looks like a plus sign. So that would be positive ion. So how does that become positive?
I don't know. I don't like cats.
You don't like cats. Well, I don't like cats either, but this is a different type of cat. So, how does that become positive?
It just does.
What's that, Austin?
It just does.
No, a little bit more than that.
Chemical bond.
It has more positive than negative. Well, I mean, like it's protons.
More protons than
Than
electrons.
yeah.
So, how does it get more protons and electrons? What happens to the atom that allows it to become positively charged? No, we don't split an atom. That'd be nuclear, and that's not probably
Maybe
what.
they interact with another.
Yep. Yep. Eventually, they're going to interact, so they can. You guys are exactly right there. I bet you somebody knows how that becomes positive charge. So we got these three things in the atom, right? We have protons and neutrons. Where are they located? In the center. All right. So we got this atom here. We got protons and electron, or not protons and electrons, but protons and neutrons in the center. Okay? So, where are electrons? Outside. Right, now, with that information, can you tell me how that atom becomes positively charged? So right now it's neutral. It has the same number of protons as electrons. How does that become positive charge? Loses electrons. Atoms never lose protons or neutrons. Okay, they always lose electrons or gain electrons. So cation becomes positively charged because it will lose electrons. It loses electrons. All right, so anion. You guys be able to tell me what that is. So, what's an anion? Yep, it's a negative ion. Very good. So you guys remember some things that we've talked about. I don't know how many people got these switched around on the test, though. Because people would say, I said, well, what's a cation? And they'd say negative ion. And then they'd say, well, how's it form? And they would do the opposite. So think of that plus as positive charge. So anions, they're going to what with electrons? Gain. Okay, and that was another thing that some students struggle with. They're thinking if it gains, then it's going to be what charge? They think positive. Well, if it gains, it's got to be positive, because anything it gains, it's got to be positive. But it's gaining a negative charge, so it becomes negatively charged. So anions. So what happens to these two when they become positive and negative? What will they tend to do if they're around one another?
Attract.
Yeah, they'll attract, because opposites attract. So guess what? Ionic bonding is when these cations and anions come together and they form a compound. Now, they had to come together in a particular way. You guys remember that, for example, sodium was a +1 and oxygen is a -2, and we said they had to come together to where the charges need to be balanced. So does anybody tell me the formula for NaNO? Yep. Thank you, Austin. Na2O. Sodium oxide. So, last semester we really focused upon, first part, ionic bonding, looked at that. And we didn't really talk about this other thing that we're going to talk about here in a second. And I'm going to have you turn the page over, and I'm going to have you read the first 2 paragraphs of page 300. What do we call that location and where they're located? What's that called? The what? The shell. Okay? They're called shells. And that's kind of a general description of where the electron's located. And we have multiple shells. Because you would think of a shell that it's kind of an outer portion of something, there's something inside of it, like a nutshell, for example. Okay? But we're going to have multiple energy levels or multiple shells that we're going to talk to you about. So, the shell is where the electron is located. So, if you want to write down notes, you can now. But shells are locations of electrons in an atom. We find out it's a lot more complicated than just specific orbit. We think when we see these shells, it looks like an orbit, like the moon orbiting the Earth, for example. Okay, but it's not that simple. But we're going to try to keep it as simple as possible for now, so you can visualize where these electrons are located. So we've got this nucleus that's in the center. Okay, we'll represent by the large circle there. And then we have the first shell that's located around that nucleus. Tyler, how many electrons can that shell hold? So look in your reading, in the second paragraph it talks about, right at the end it talks about 2 shells.
The second shell?
The first shell, how many can it hold? 2 electrons. I want you to look across the periodic table, the very top period. How many elements are in the first period across the periodic table? 2. That represents hydrogen and helium. Hydrogen would have just 1 electron, and helium has 2 electrons. Okay? So then what happens after that? That shell would be considered full when it has 2 electrons in it. Here's the second shell. How many can it hold? 8. 8. I want you to look at the I want you to look at the periodic table and count across the second row. How many elements are in the second row? 8. Now the periodic table is telling us a lot now. It's telling us how many electrons are in the first shell, first row, second shell, second row. How many is in the third shell? 8. And it continues on that way. Okay, so when we get down to the fourth row, there's 18 across that row or that period. We're not going to include the middle block of elements. All right, we're not going to count the middle block of elements, and don't ask me why. Maybe 1 or 2 days of explanation, and I'm going to do that. But we're never going to count the middle grouping. You say, well, those aren't important. Yeah, they're very important, but we're not going to count those when we count how many electrons are in the outer shell. We're not going to use those in which to do any examples with. Okay? Questions? 2, and then from then on, 8. The most that the outer shell can have in it is 8. It's kind of like how many notes are in a musical scale that you would play. You guys are in music or a bit of music. So let's go ahead and play the C scale. How many notes are you going to play? You know? 8. Go up an octave. Okay, here's a C, here's up an octave. Okay, it's the 8th note up. So think of this as these are going to be 8 electrons in the outer shell. Emma, do you have a question?
That's how it is for all of them?
That's the way it's going to be for all of them when we talk about bonding. Now, if we got into it, some of these shells can have more than 8, but for looking at bonding and how things bond, they're always going to be based upon having 8 electrons in the outer shell. Okay? Now, if you go in the next higher level of chemistry, then we would talk about, they don't maybe have 8, they have more than that, but when for bonding in that class, we always talk about 8. 8 electrons is the most they can have. Okay? All right. So, let's draw a couple of these out and just to see if they draw out right. Okay? You guys help me out. So, let's do calcium. So, calcium is element number 40. So, how many shells are we talking about? First shell has 2. Second shell has 8. Is that right? Okay. Third shell has 8, right? Fourth shell has how many? I guess it has 20 electrons. So I've got 18 drawn. 2. Now that's a lot of work, and we don't want to do that every single time. So what we're going to focus upon is outer shell electrons. So how many electrons are in the outermost shell of calcium? You guys with your head down, you guys need to get your heads up. Okay? Austin, guys? Okay? How many electrons do we have in the outermost shell? 2. And those are called valence electrons. Those 2, now we don't care about, unfortunately, I don't want to make these electrons feel bad, but we don't really care about these electrons in here. They're not involved in bonding. Okay? What we care about is the outer shell electrons, and those are called valence electrons. Okay? Write that down in your notes if you would. Valence electrons. Valence electrons are the ones, guess what they do? They are given up, they are accepted, lost and gained, they are shared. The inner shell electrons, anything inside the outer shell, they're not involved in bonding. It's only the outer shell that's involved in bonding. Okay? So you can think of a football game, for example. You've got the line, and they are kind of the ones that are involved in that first level of blocking. They are super involved. And then, you know, the other people, later on, they would get involved. But that outer shell is the one that comes in contact with other atoms for bonding to occur. Okay? The electrons that are located in the outer shell of an atom. If you would write that down, we will come up with a better way to write all those electrons in. If those inner shell electrons do not matter, why do we even, show them? And we'll explain here that we're not going to show them. But we have to figure out a way to determine the outer shell electrons. Okay? So that's what we're going to do next. We're going to do a couple examples of that, and then we'll take our short quiz that we have. I will give you an easy way to determine valence electrons. Okay? For any element, the maximum is 8. And the least we'd have is 1. So your answer would be 1 through 8, depending upon how you want to set it up. Okay? Alright, so let's look at how we would do calcium an easier way. Alright, here's how we do calcium without showing all 20. We would go down to the row calcium's at. So we go down 4 rows. 1, 2, 3, 4. It's in the 4th row. Then we would count across, counting potassium is 1 and calcium is 2. So we go potassium, you're 1, calcium, you're 2. As we go across that road. That tells us the number of valence electrons in the outer shell. So how many electrons does calcium have in the outer shell? What do we say? 2. There it is. So that's how many valence electrons it has. Let's try another one. How about phosphorus? How many electrons does phosphorus have in its outer shell? So you go down the row, phosphorus in, and you count across. How many does it have?
15.
Okay. So here's phosphorus, and we count across. 1, 2, 3, 4, 5. 5 valence electrons. 5 in the outer shell. Okay. So phosphorus has 5 electrons. Let's do another one. How about argon? How many valence electrons argon have?
8, 7. God, it's
8. If you notice you're at the end of the row, that is the maximum amount that can be, that it can have, is 8 electrons. Okay? And I'm not going to have you doing these on your own. Well, let's do 2 more, and you guys tell me how many electrons it would have. So, let's do gallium. Now, with gallium, let me give you a hint. You can only have 8. And if you start counting across this middle group, you're going to have a lot more than 8. So this middle group is not involved in counting. It's only this kind of column here, these first 2, and the last 6 that you count across. Don't count any of the middle group.
Is it 3?
How many?
3.
3 electrons. Very good. Thanks. 3 electrons for gallium. Got it? Last thing I'm going to have you do is I'm going to talk to you, and this is what you're going to have to do tomorrow. We're going to talk about this idea of electron dot notation. So we're going to combine what we did with the circles and with counting valence electrons and include it in what's called valence dot or I'm sorry, electron dot notation. I'll do the first one for you. You're going to do 2 for me. So I'm going to do silicon. How many electrons, valence electrons, does silicon have? Si. How many? 4, right? This is electron dot notation for silicon. I'm going to show 4 dots around it. Look up here. That's what I'm going to show. Instead of all those circles, I'm going to show that. How many does that silicon need to get 8 in it? How many more electrons does silicon need? 4 more. Okay? You guys help me out with this one. I'm going to go ahead. Let's do bromine. How many valence electrons does bromine have? 7. 1, 2, 3, 4, 5, 6, 7. So that's what you're going to show. 7 dots. Instead of showing all the circles and all the inner electrons and all that garbage, we're just going to do the outer shell. Okay? One last one. Let's do arsenic. Fine. 1, 2, 3, 4, 5. That's it. So that's got electron dot notation, and we're just showing the outer valence electrons, and that's all we need to do. So go ahead and grab a sheet of paper. This will take less than 10 minutes, and you're going to answer these 4 questions on that sheet of paper. So go ahead and get a piece of paper. Austin, you got to get out a piece of paper. Okay, most people have been doing really good on this. Most people aren't missing any. If they miss one, it's number 2 that they miss. Okay? So when you're done, you'll hand that to me. We'll kind of see where you're at individually on what you're able to gather with what we talked about today. And hopefully you'll get them all right. Okay? First question. Draw a diagram of aluminum showing the proper number of electrons in each shell. Okay, so take aluminum, draw out a diagram of what an aluminum model would look like with the proper number of shells and the proper number of electrons in that shell, in those shells. Okay? This is a Bohr's model. We don't really deal with the Bohr's model anymore. This is the first, not the first model, but second or third model of what the atom was supposed to look like. It's a really good model for us to kind of show where those electrons are located and what energy levels they're located. Okay? So that's the first thing I want you to do. Second thing I want you to do is to give me the term that represents the bonding that has electrons being lost and gained by atoms to form charged ions. So what bonding involves atoms losing and gaining electrons by atoms? What kind of bonding is that? First, draw diagram of aluminum showing the proper number of electrons in each shell. And second, what type of bonding has electrons being lost and gained by atoms to form charged ions. Okay. Question number 3 involves something we just learned, and you just have to draw them out. It goes with electron dot notation. So question 3 says to draw the correct electron dot notation for those following atoms: beryllium and nitrogen. So the dot notation, that's the ones where you had the symbol you used, and not the circles. And the last question, real similar to this one. How many valence electrons will the following atoms have? You have silicon, you have chlorine, you have sodium to do. So how many valence electrons will the following atoms have? You just have to write how many it has. And when you're done with that, I'll collect it, make sure your name's on it.